Hey guys, today I'm going to show you guys how to replace an electrical wall socket or a receptacle today. This is just a little quick video. I have two pretty old wall sockets that when you plug something in they just fall out and they're pretty much worn out. I mean, these things have been here since the building was built, and this building was built quite a long time ago, so it's time to replace them. I'm just going to do a standard 15 amp receptacle, duplex receptacle, which is exactly what is in right now, but it's just going to be a new one. So the tools that I'm going to use are quite basic. It is a flathead screwdriver, a Phillips screwdriver, wire strippers. These ones are my electrical ones, and they have a return spring on them, and they're really nice. And most importantly, I would actually have to say, is the voltage tester. This thing will detect if there is electricity. As you hear the beep, that means that there is current going through there, and that means the wire is live. Once it's dead, it will just stay green like this and won't have any ringing to it, or it won't change colors. So this is kind of like your safety device to make sure that what you're working on is going to be safe. And yeah, so I'm going to be using this guy, and I highly recommend that you guys get one of these. This is a Klein Tools voltage tester. And then another thing is safety glasses, just in case for any reason anything goes wrong. It's always nice to have something to protect your eyes, because you only got two of them. Alright, so I'm going to turn off the breaker, and then I'm going to move the camera a little bit closer to get a good view of it as I work on it and show you guys what I do. Okay, so I turned off the breaker. As you can see, there is no power being read, and that means it's safe to work on, so I can put this away for now. Alright, so it's kind of weird. This one has like a metallic box in here. Usually you see plastic, but for some reason builders decided to use that. They probably just ran out of things, but usually you see a plastic blue box or something, or a gray one. It doesn't really make a difference, but yeah, it's just kind of, for me, it's interesting to see. It's like kind of an exterior box, I want to say. I don't know. Maybe it's just an older box. I don't know. I don't know how old this house is. So yeah. Actually, I do know how old this house is. It's not that old, so I don't know why they used this box. But first off, you're gonna take off the mounting screws for the receptacle, and I'm probably gonna have to reuse these ones because I didn't buy any new ones, which is fine. These screws are fine. You're not gonna see it, so that's all right. All right. So now that that is off, you can wiggle it out and pull out. Ooh. Your wires. Okay, that's a little dusty. That can be a fire hazard if you have just a bunch of dust caked in there. So I'm gonna just pause the video. I'm gonna vacuum this out and clean it out. It's just, I want to do that because I don't want anything to spark in here. For God forbid that it does, and then starts a fire in here. So yeah, I'll be right back. Okay, so I just kind of cleaned it out a little bit. So rule of thumb, or if you're confused at which new receptacle to buy, usually when you take the cover plate off, right in the middle between these two outlets, there is there's some numbers and stuff on here. It will say 15 or 20 amps, or 20A, 120 or 125 volts. So this one is a 15 amp 125 volt receptacle. So what I bought is a 15 amp 125 volt receptacle replacement, and this was only 79 cents at local Ace Hardware. So yeah, I picked up two of them. There's nothing special about these. They have some that have little plastic inserts that make them tamper resistant, so you can't shove like metal objects or something into it, but those were like a couple dollars, and honestly this is just fine. This one lasted for probably more than 20 years, so this one's gonna last probably just as long. So now for the wiring back here. As you can see, this one, it doesn't have screws on the side like this guy. This guy has silver and brass screws, and I'll get to those in a second. This one has a push-in, which is, they still use those today, but I don't know, I just didn't see one like this at the store, so I bought this guy. So basically what these are is you strip the wire, the insulation off of it, and then you just push them in, and there's like a barb or a clamp in there that holds the wire in there so they can't be pulled out, which honestly I really like. We use these at work all the time, and they're pretty cool. But I'm going to show you how to wire up this guy, because this is probably the one that you'll find at the hardware store, most likely, because I did, and they're the cheapest ones. So to get these off, I just cut them off like so. So you have a black wire, which is your hot, or the wire that supplies power, and then you have a white wire that is a neutral. So it's like a return path for I think excess energy. I might be explaining that wrong, but it's a return path for some sort of energy. I know that. And then you have usually a bare copper wire or a green wire, and that one is called the ground. So if anything does go wrong and you have power coming out, instead of shocking the person or the energy going into something, another object, it usually will go on the ground and be dissipated into the actual ground of the earth, because there is a grounding rod usually on your house. It's like a long copper rod, or they've attached a grounding clamp to a metal pipe that goes into the ground underneath your house, and then the energy will be dissipated safely there rather than into you. So yeah, that's your safety, your lifeline. So I've taken this one off, so I'm going to put this to the side, and now we are going to be attaching this one. So brass and silver, you got brass screws and you got silver screws. So silver is white or neutral, brass is black or hot. Brass is always black or hot, neutral is silver. So the way I'm going to do this, and it's really nice if you have these specific wire snippers rather than the ones that look like kind of like a wrench that have the strippers down here. This one is good for a couple reasons that I'll show you. So a lot of these will have a strip gauge. This one has a strip gauge right here. I'll get a close up in a second, but it kind of tells you how much to strip the wire. But I kind of do this all the time, so I kind of already know. That's another reason why I like this one. It's just so quick. All right, so this one actually does have holes in the back where I can put the wire, and this is for 12 gauge solid wire, which this is. So a lot of times you can either loop it around here, or you can just stick it right in the back and then call it a day. So what I'm probably going to show you, because just poking it back there and tightening down the screws is really easy. It's really straightforward. You just line up the hole and you shove it in and you feel it grab, and then after you just tighten both screws down on both sides after you've landed the screws. But this one, I just want to show you guys how we kind of do this. Let me see, this is how no, it does not. Okay, so on these guys, it has a hole right here. So what this hole is for is actually making loops, specifically to go around screws, screws. Sorry. So I have a little, I don't know if you see that, little kind of half circle right there. So what I'm gonna do is loop that around. I could probably make that a little tighter, like that. And another little trick, you don't really need to do this, but the way that this screw is going is clockwise. It's going to be turned clockwise. So if I have the opening this way, theoretically, if I get down where it's touching it, it could start opening up this little loop. So what I'm going to do is just twist it the other way. So now it's facing that way. So when I screw down this this screw right here, it's going to close it around the screw and keeping it tight on there. We got to open it up a little bit. There we go. Now it's on there. Just making sure. Go. Now I'm going to tighten this guy down. Make sure it's snug. You can use your flathead screwdriver if you want to make sure it's nice and snug. Don't do it too much where you strip the screws, because that's a bad thing. Now this bottom screw I'm using both the tops. This bottom screw just tighten down since it is conductive, and you want to keep it out of the way, especially since this is a metal box. Usually they're plastic, which is a little bit safer, but this one's metal. But regardless, you always want to tighten all screws down. You don't want anything loose, especially on something that that's energized. Alright, so this one I'm actually going to strip a little bit more. The other one was a little bit close. That's good. Okay, that's actually perfect. That was better than the first one. I'm going to screw this guy down. Okay. Just gonna hit it with a flathead screwdriver real quick. That's good. And this green one down here, that will be your ground, where the bare copper or the green wire will go. Now, the top of this has some plaster or paint or whatever, so you can either clean it like that, or in this case, I'm just gonna cut it a little bit shorter just to show you guys how to do another loop. Cut a little bit off, a little bit extra off of there, just because I want to get to the nice clean wire. Now I've got my loop again. This one's a little bit more exposed, so once I get it on, I can kind of pinch it with the tips of these. So now it's pinched around there, and that's good. Or Phillips head for right now. Okay, hit it with the flat. Boom, there we go. Oops. Alright, so there's wiring back here, because there's a line and a load, which means power comes in, comes out to here, and then power also goes out to another receptacle down the line. So these guys I haven't touched, and basically what I'm going to do is kind of fold the wires kind of accordion style like that, just so they're out of the way. Push this guys back, make sure they're not in the way. And this one, I don't know why, but this one, I don't know why I forgot about this, but they always come with new screws, so I don't need to reuse those old ones. And now I'm just going to screw this guy in and then put a cover plate. So these little pieces right here actually usually touch the outer wall of the drywall, and it kind of keeps it flat with for the cover plate. A lot of times these are cut too big, and then you have to put spacers. But I think I might get lucky. They're actually touching it just perfectly, and I'm making sure that it is level up and down, and it's not bent either way. If it is bent, like let's say it was kind of bent this way, or it wasn't flat with the wall, I'll take it out, bend it the opposite way so the wires get corrected, and then attach it back in. So now that's good. So now I can attach a cover plate. This is I think this was 53 cents. This whole thing was like $1 something. And these also come with a screw, so it's all brand new. Get that guy lined up. As you can tell, there is a gap down here where the receptacle is a little bit lower, or a little bit into the wall. So I'm just gonna kind of open that up a little bit. It's not really moving that much. That might be a little bit of a play, but this cover is gonna kind of hold on to it, so it's not gonna be moving that much. Yeah, there we go. No play. And there we go. That's a finished receptacle. So that was just a little quick video I wanted to do on how to replace a receptacle. And yeah, it's really easy. You just got to find the breaker. Turn it off. Make sure no one turns the breaker on you when you're working on it. And then it's safe, simple, and it's honestly, it's really fun. I like it. All right, thank you guys, and I'll see you next time.